False. Fault is an abnormal condition. The data logger, based on the logic embedded in it, will identify this abnormal condition. The user in their requirements will give the logic behind the fault. Faults are of two types: digital faults, analog faults. Digital faults. Digital faults checks for the conditions defined by the user. Example 1. Push button failure. When a push button is pressed, then button should return within a specified period of time. If it does not return, then a fault is to be occurred. The user will specify the time. Example 2. Point failure. When NWKR or RWKR is not picked up within specified time after pickup of WNR or WRR, then a fault is to be generated. This time interval will be defined by the user. When a digital fault occurs, data logger will activate the buzzer. These faults can be viewed on LCD screen by using keypad. These faults can be viewed in two modes: online mode, offline mode. Online mode. There are two ways to identify the latest faults in online: through LCD, printout. Digital faults identification through LCD online mode. When a fault occurs, data logger will activate the buzzer and it will display the corresponding message on LCD. Data logger will keep the track of the latest fault occurred and will be displayed on the LCD. For that, user has to follow given procedure. At the main menu, press key 1 on the keyboard. The following screen will appear. Press 5 key to select the FALT false option. Then the following menu will appear on the screen. This menu is called false menu. Press 3 key to select the latest fault option. This option gives the latest faults occurred, if any. The following screen shows a sample fault. Here 001 will represent the fault number that has occurred. 24TEC10 will represent the date, month, year. 1817 will represent the time of occurrence of fault. 1A TPR track circuit failure will represent the fault name. Digital faults identification through printout online mode. Follow the same procedure that explained in digital module to take the printout for online digital faults. In the printout, the corresponding fault message will also get printed. By observing the related input status, user can validate that false. Offline mode. In this mode also there are two ways to get the information about digital faults: through LCD, printout. Digital faults identification through LCD offline mode. Data logger is having the capability to store the status of 500 latest faults. To see the status of faults occurred in offline mode, follow the given steps. Press the key 1 to select the DGTL fault option in fault menu. Then if any fault has occurred previously, user can be able to view its status on LCD. Since the data logger would be able to store the status of 500 latest faults. To view the status of next fault, press the hash key. To view the status of previous fault, press 0 key. To view the status of last fault occurred, press key 2. To view the status of first fault occurred, press key 1. If no digital faults are occurred, then the following screen will appear on the screen. Digital faults identification through printout offline mode. Follow the similar procedure to get printout of digital faults in offline mode as explained in digital module. Analog faults. If any analog channel voltage is not within its maximum and minimum voltage range, then analog fault is to be occurred. When analog fault occurs, then the buzzer will be activated. User can get the analog fault information in two modes: online mode, offline mode. Online mode. User can identify the latest analog faults in two ways: through LCD printout. Analog faults identification through LCD online mode. Follow the similar procedure to get the online information about the analog faults as explained in digital faults. Analog faults identification through printout online mode. Follow the similar procedure to take the printout for online analog faults as explained for digital faults. Offline mode. In this mode, there are two ways to get the output of analog faults: through LCD printout. Analog faults identification through printout offline mode. Follow the similar procedure to get the printout of analog signals in offline mode as explained in digital faults. Analog faults identification through LCD offline mode. Follow the given procedure to view analog faults on LCD screen. Press 2 key to select the analog fault option in faults menu. Now the user would be able to view the analog faults if it occurs, since the data logger would be able to store 500 faults. To view the status of next input, press key hash. To view the status of previous input, press key 0. To view the status of the latest analog fault occurred, press key 2. To view the status of the first analog fault occurred, press key 1. An example screen is given when the analog fault occurs. 016 signifies the fault number occurred. 20DEC10 signifies the date, month and year. 1817 signifies the time, hour, minute, second. 110 VAC signifies the channel name. LOW signifies the status of fault occurring. 0.2100 V signifies the voltage value at which the fault has occurred. If no faults occur, then the following screen will appear on LCD. Flash memory in data logger. In data logger, flash memory chip is used for data backup of more than 10 lakh events. User can see the flash memory chip status that is placed in the data logger. To see the status of the flash memory, follow the procedure as mentioned here. When the LCD is in default display menu, press star key to go to the main menu as shown. Then the following screen will appear on the LCD. Now press key 3 for viewing the status of flash memory. Now the screen will be as shown. For viewing the health status of the flash memory, press key 1. Now the screen will be as shown. If the flash memory is healthy, if the flash memory is failed, message will be displayed as shown. If the 68K processor to 89 LPC 936 controller communication link is failed, message will be displayed as shown. For viewing the bad clusters information in the flash memory, from this screen press key 2. Now the screen will be as shown. For viewing the number of packets stored in the flash memory, from this screen press key 3. Now the screen will be as shown. For viewing the date of the oldest file and the latest file stored in the flash memory, from this screen press key 4. Now the screen will be as shown. Copy files from flash memory to external memory card. User can copy the files from flash memory to external memory card in the data logger. To do that, external memory card is to be inserted into data logger and follow the given procedure. When the LCD is in default display menu, press star key to go to main menu as shown. Then the following screen will appear on the LCD. Now press key 4 to copy the files into memory card 2. Now the screen will be as shown. Now users have to enter from date and to date of the files to copy and press star to start copying. If the entered dates are not valid dates, then the screen will be as shown. If the entered from date is greater than to date, then the screen will be as shown. If the entered dates are valid dates, then the screen will be as shown. In this screen, if you press hash, then it will be as shown. If the memory card is not present, then it will be as shown. If the flash memory is busy, then it will be as shown. If the data available in the memory card 2 is not a valid data, then it will be as shown. If there is not enough space in the memory card 2 to copy the requested files, then it will be as shown. When files are being copied into the memory card 2, then it will be as shown. When copying is finished, then it will be as shown. Various functions in Data Logger. Data Logger has following extra functions: time and date setting, change of password, packet information, configuration details, digital cards health status information, procedure for changing date and time. Follow the given procedure to set the time and date of the data logger. In main menu, press key 1 for selecting the data logger options. Now the following screen will appear on the LCD. Press key 1, then following screen will appear on the screen. By pressing any key to change the time, the following screen will appear. Now enter the password. By default, the password is 123456. If the entered password is incorrect, then the following screen will appear on the LCD. Press the key star to return to the default display menu. If user enters the correct password, the following screen will appear. Now, update the required date and time in the fields. To move the cursor between the fields, press the key hash. Now, after updating the fields, press the key star. Then the following screen will appear. Press the key hash for effecting the changes. Press star key for cancelling the changes made in the fields. When the hash key is pressed, then the following screen will appear on the LCD. When the key star is pressed instead of hash, then the following screen will appear on the screen. Press star key to return back to default display menu. Changing data logger password. This feature was developed to provide authenticity for the user to change the analog database and the time. 123456 is the default password present in the system. To change the password, go to the main menu. In main menu, press key 1 for selecting the data logger options. Now the following screen will appear on the LCD. Press 8 key to select the password option. The following will appear on the LCD screen. Now enter the old password if any, or enter the default password 123456. If the entered password is correct, the following screen will appear on the LCD display. Now enter the required password, then it will ask again to enter the new password as which is shown. Then re-enter the new password for confirmation. If the re-entered password matches with the previously entered one, then the following screen will appear. If the re-entered password does not match with the previous one, then the following screen will appear and the old password remains unchanged. Packet information. Packet means an event record which contains some information of a data logger. The information may contain the digital input status or analog status or fault status, etc. Total packets indicate total number of packets generated locally in the data logger. To view total number of packets generated locally in a data logger, follow the instructions given. When the LCD is in default display menu, press hash key. Press the key 1 to select the PKTS option. Then the screen appears as given. The count given nearer to the total packets option indicates the number of packets generated in that data logger, and the count at PEND packets indicates the number of packets yet to be transferred through computer port commonly used in standby mode. Data logger configuration display. System configuration. This option gives the configuration of data logger system. This configuration includes the following information: configuration, checksum value, data logger on-time information, communication status through analog ports, port configuration information, configuration. By pressing the hash button at default display menu, the following configuration menu will appear on the LCD screen. Press 2 key to select the config option. Then the following screen will appear. 065 indicates data logger identification number. D01S003H03 indicates version number. D0512 indicates number of digital inputs. A96 indicates number of analog inputs. 4M indicates 4 MB RAM contained in the data logger. Now again press key 2. It will display the checksum value of the monitors as shown. Now again press 2. Then it will display the data logger power on time as shown. On the first row of the screen, power on time will be displayed, and on second row, the communication details of analog and network ports and the type of the protocol 554P indicates communication IC is 16 C554 and the makes is Philips. Now again press 2. Then it will display the communication status of analog channels through analog ports as shown. By pressing the hash key at this screen, it will display the communication status of the next analog ports. Now again press 2. Then it will display the port configuration information of all ports as shown. NW indicates port type, network or relay, HUT or analog, etc. M1 indicates module number. MDM indicates type of communication, modem or current loop. CRC indicates validation type, cyclic redundancy, check or checksum. By using the hash and 0 keys, we can know the next or previous port configuration respectively. In any of the given steps, by pressing the star key, we can go to default display menu to change the analog database. This utility gives information about analog database. By pressing the hash button, the following menu will appear on the LCD screen. Press the key 5 to know about the analog database contained in the data logger. All the parameters concerned to analog voltages can be seen on the screen. Press hash key for viewing the information regarding the next channel in this. 001 indicates channel number. 230 VAC indicates channel name. 330 indicates multiplication factor. 0010 indicates tolerance in terms of 0.5 count. 170 indicates minimum voltage. 280 indicates maximum voltage. Multiplication factor, this is the possible maximum voltage for that particular channel. Tolerance is the maximum percentage voltage variation limit, beyond which if the actual channel's voltage exceeds, then that value will be recorded in the data logger. Tolerance will be measured in percentage values. The number given here represents the multiples of 0.5 value. Example, for the value 4, percentage of tolerance is 2%, that is 4 into 0.5 by 100. User can set the tolerance value from 1 to 20, that is user can set the tolerance up to 10%. Authenticity is required for changing the analog database, but the data flash RAM in the concerned position of the CPU card. Now from this menu, Analog Database Display, press any number between 0 to 9 for getting the password menu as shown. Now enter the valid password. Now if the password is valid, then the system will be ready to change the analog database. User has given provision to change only the tolerance minimum and maximum voltages for the analog database. Now the user can change the database by using the following keys. Each key is having different functionality. The significance of the different keys is given. Key 1 is for increments the parameter by 1. Key 2 is for add 10 to the present value. Key 3 is for add 100 to the present value. Key 4 is for decrements the parameter by 1. Key 5 is for subtracts 10 from the present value. Key 6 is for subtracts 100 from the present value. Key 7 is for go to the next field, that is minimum or maximum voltage field. Now, after making the necessary changes in the analog database, press star. A message appears for updating of the changed values as shown on the LCD. Press hash to update the values and store them permanently into the flash RAMs, or press star to ignore the changes. When the values are updated into the flash RAMs, then the following message will appear on the LCD screen. Now press star key to return to the main menu. If the user tries to change the database without putting the flash RAMs, then the following message will appear on the LCD screen. To see digital card status, this option will represent the digital card's health status. To enter into this option, press key hash from the main display screen. Then press the key 6 to select the option DCS, Digital Card Status. When the key 6 is pressed, then the first 8 cards' health status will be displayed on the screen. If a particular card's health status is fine, then it will be represented as OK. If a particular card is not properly inserted, then it will be represented as CF, that is card failure. If a particular card's transistor is failed, then it will be represented with TF, transistor failure. Thus, at the first attempt of pressing the key 6, the first 8 cards 1 to 8 status will be displayed. When the key is pressed once again, then the next 8 cards status 9 to 16 will be displayed on the screen. This process will be continued until all the 64 card status will be displayed on the screen. For example, if all the first 8 cards health status is fine, then the screen will appear as shown. For example, if the second scanner card's transistor has been failed and the 8th card is not properly inserted, the screen will appear as shown. To do modem reset through keyboard, this option is to reset the modem's port through the keyboard option. To do this, press the hash key from the default display screen. Then the following screen will appear. Now press the key 7 in order to select the MDMR option, that is Modem Reset option. When the key 7 is pressed, the following screen will appear on the LCD. Now select the required port which has to be made reset and press the concerned number on the keyboard. If, for example, the user wants to reset the modem connected to the port 1, press the key 1 on the keyboard. Then the following screen will appear. It means that the concerned modem has been made reset. Similarly, reset the modems connected to other ports by pressing the corresponding key on the keyboard. Note, the modem will be reset after 1 minute of pressing the key. To see RTU data in the data logger, user can see the remote terminal unit RTU inputs status which are configured and connected to the data logger. To verify the inputs status of the RTU, follow the procedure given. When the LCD is in default display menu, press star key to go to main menu as shown. Then the following screen will appear on the LCD. Now press key 2 for viewing the status of inputs of RTU. Now the screen will be as shown. For viewing the digital input status of the RTU, press key 1 Now the screen will be as shown. For viewing the analog channel voltage of the RTU, press key 2. Now the screen will be as shown. In this screen, RTU001 indicates the RTU ID. Date and time indicates the date and time of input status change. On second row, name of the input or analog channel name and its status of the voltage will be displayed. Internal buzzer options for fault alarms. User can set different options for internal buzzer. They are: disable permanently, enable for a timeout of 3 seconds, enable permanently until acknowledgement key pressed. This selection can be done by pressing the key 7 at default display menu. By default timeout, 3 seconds will be given. Example: for disabling the internal buzzer, the following sequence of key options should take place. Now press key 1 for disabling the internal buzzer permanently. Then the following screen will appear on the LCD. In the same way, we can select any mode for internal buzzer in data logger for fault alarms. The PC which is used to view data logger reports is known as Failure Analysis System. Following minimum configuration PC is to be used as FAS. Intel Pentium Core 2 Duo, 2 GB RAM, 160 GB hard disk drive, 1 serial port, GB Ethernet port, CD DVD drive, Windows XP operating system, Kaspersky or Norton antivirus. Install the Nmdl install shield. For detailed procedure for installation, click here. Ensure that the date format is in month, date, year in regional settings of control panel. Upgradation of data logger software mainly consists of updating the latest data scale.gdb in C drive NMRH SKEL folder. Updating the chart with latest yard diagram and place the chart files .dat in C drive NMRH chart path. Place the latest fault folder in C drive NMRH folder. FAS is used generally at 3 places: as a local PC connected directly to data logger, as a PC connected in LAN to view data from the database server at test room, as a PC connected to the test room LAN from a remote place CSI ASTE office. In cases where a local PC is non-existent, sometimes it may be required to collect data by using a laptop. Laptops generally do not have a serial port. To enable us to collect data logger data through the existing USB ports, following is the procedure. Data logger should be interfaced with laptop or PC through a MOXA serial port adapter cable. A 232 serial port connector should be connected in series to the MOXA cable serial port. For laptops having 2.0 type USB ports, any USB port can be used, and for laptops with USB 3.0 type ports, only eSATA USB ports are to be used for USB to serial connectivity. After the MOXA cable is connected to the laptop's USB, a COM port is automatically added in the device manager as well as in the Nmdl software. Only after making this connection, Nmdl software should be opened. Now we find the COM port listed in the communication settings screen of Nmdl for selection. How data loggers are connected in a network. Data loggers are connected to one another through voice channel or a quad cable by leased line modems. Software available in the data logger ensures that the data packet generated by it is handed over to the next data logger. Similarly, it receives the data generated by the adjacent data logger. Front-end processor FEP is installed at the central place. It consists of up to 8 leased line modems and memory for storing 10 lakh events. Nearest data logger is connected to the FEP. The data thus reaches to the central location where data is required. Data is first stored in front-end processor FEP. Data from FEP is collected in a PC by the help of a software called Nmdl, Network Management of Data Logger. This PC is called CMU, Central Monitoring Unit. If more than one user have to view the data and reports, another PC is required in which reports software is provided. This PC is called FAS, Failure Analysis System. Basic network diagram. Limitation: any one failure causes data loss. Solution: provide end patch to have bidirection data flow. Issue: too many data loggers in one loop. Solution: limit number of data loggers to less than 10 in one loop. Issue: too many data loggers in one FEP. Solution: limit the data loggers to 32 as stipulated in RDSO specification. Issue: data cannot be viewed by multiple users. Solution: provide server and DBMS, database management system. Issue: too much of data. Solution: provide multiple servers. Issue: increasing reliability by redundancy. Failure of FEP, CMU or software in them causes loss of data of many stations. To avoid it, redundancy of these equipment is catered. Behavior of data transfer in case of communication medium failure. Places to which data is required to be extended. Test room, control office various departments, field supervisors and officers' office and residences, divisional officers' offices and residences, zonal office. Network diagram for extending the data to remote users. If more than one user has to get the data, the network requires modification. Hardware required for extending the data: server, firewall, modems, communication channels, LAN extenders, software required for extending data to remote user, database software, antivirus software, network operating system software, PC, Intel Core i7-8660 2.8 GHz 8 MB cache or latest, 2 GB RAM or as required for latest OS and application software, 500 GB hard disk drive, dual gigabit Ethernet ports, 2 serial port, keyboard USB, mouse USB optical, Windows 7 Professional Operating System, Kaspersky Antivirus, 22-inch TFT monitor, one number, make HP or IBM or Dell. Note: One additional PCI VGA card to be procured for PCs provided in the test room. One 40-inch monitor to be procured for signal monitoring of each section consisting of about 32 data loggers. One 22-inch monitor along with a KVM switch to be procured for data logger network monitoring for each section. Server Intel R Xeon R X5650 2.66 GHz 12 MB cache or latest. 16 GB RAM 4x4 GB or as required for latest OS and application software. 4x600 GB 15K RPM. RAID controller 512 MB cache. Dual gigabit Ethernet ports. Redundant power supply. DVD writer SATA. Keyboard USB. Mouse USB optical. Windows 2008 Server Standard Edition 64-bit. Kaspersky Antivirus. 22-inch TFT monitor, make HP or IBM or Dell. Firewall, make CyberRoam 25IA or similar. 10 or 100 or 1000 GBE port. Configurable internal or DMZ or WAN port. Console port, RJ45 or DB9. Input voltage 170 to 240 volt AC. LAN switch layer 3 to 24 port. Connector RJ45 10 or 100 or 1000 base T ports 24. Combo SFP slots. Open slot for 10 gigabit uplink modules. RS232 console port. L3 routing. Floating static route. Policy-based route. Multiple IP interfaces per VLAN up to 5. Power supply 110 volt to 240 volt AC. LAN switch 24 port. Connector RJ45 10 or 100 or 1000 base T ports 24. Power supply 110 volt to 240 volt AC. LAN extender. LAN interface. RJ45 connector. 10 or 100 base T auto negotiations. Auto MDI or MDI-X. LED. LAN ACT or LNK 10 or 100 Mbps. VDSL power on or off. E1 converter E1 to Ethernet between E1 in OFC room and field official PC if Ethernet port is not available in the STM. Interface rate 10 or 100 Mbps. Duplex half and full duplex self-adapt. Connector RJ45 support auto MDI-X. DCE side 4-wire E1 communication. G.703 line speed 2 Mbps. Line impedance 120 ohm or 75 ohm. Connector RJ45 or BNC. Power supply rating 16 volt to 30 volt DC or 230 volt AC. Make, ANDA make or equivalent. E1 converter E1 to serial port between two data loggers or data logger and FEP. DTE side asynchronous RS232. D-type connectors supportable to a baud rate between 9600 and 57600 bits per second. DCE side 4-wire E1 communications. G.703 line speed 2 Mbps. Line impedance 120 ohm or 75 ohm. Connector RJ45 or BNC. Power supply rating 16 volt to 30 volt DC or 230 volt AC. Make and or equivalent. UPS 1 kilovolt ampere online UPS for 30-minute backup for each server separately. Make APC or Emerson or numeric. 3 kilovolt ampere online UPS for 3 hours backup for 2 servers. LAN switches, firewall, make APC or Emerson or numeric. 5 kilovolt ampere online UPS for 3 hours backup for 4 servers. LAN switches, firewall, make APC or Emerson or numeric. 1 kilovolt ampere offline UPS for 30-minute backup for each PC separately. Make APC or Emerson or numeric. Introduction. Functioning of data logger software. After installation of data logger software in CMU PC, FAS PC with install shield CD, the relevant software shortcuts are placed on the desktop automatically. The procedure to place a relevant support files related to the station database, yard diagrams and fault logic files, and the software installation from CD are need to be followed before configuring the CMU FAS PC. The CMU PC collects and processes the event data from data logger with the software known as Nmdl, Network Management of Data Loggers. The objective of this topic is to detail the steps involved in working with the various options available in Nmdl software. Nmdl software can be executed using a shortcut present on the desktop. Database connectivity. After opening Nmdl exe, database connectivity window will appear, and in that select a database. For interbase, number of days option window will appear, and in that days from 1 to 7 should be entered. And click on OK. Main menu screen will appear. For Oracle, user entry should be entered. And click on OK. Main menu screen will appear. For Firebird, select the server type like local or remote server and click Connect. Note: for remote server, enter the IP address of remote system. Introduction of password entry. A default login option is available for first-time users to avail of all the options in Nmdl software. Default login password are as follows. Username EFFADMIN in capital letter. Password EFFADMIN in small letter. After logging in Nmdl, the employee details screen need to be used to create separate login passwords for administrator level and data viewing level users. The subsequent logins should be only through the newly created logins, and the default username password will not work subsequently. Password entry. Objective: for giving some limited options to user depending on the user level in the Nmdl or reports software. Prerequisite object: different users and levels should be created using employee details entry screen. To get this option, run Nmdl software. Click on Security and click on Login, or click on Login icon on the toolbar. Enter valid username and password. Click on OK depending on the level of user. Different options will enable in Nmdl. Employee details entry. Objective: to enter different employees for accessing the various options in the data logger software. To get this option, run Nmdl software. Click Security and click on Login. Enter valid username and password. Click on Security and click on Users. To enter new values, open Employee Details screen. Enter identification name and designation and press Enter. Enter password and confirmation password and then click on Save button. Data logger setup configuration. Objective: to create the structure setup of the network. Prerequisite object: username, that is database username. Empty database in C drive NMRH SKEL folder should be created. Output: setup of the data logger network will be created and default signal names will be created. To get this option, run Nmdl software. Click Security and click on Login. Enter valid username and password. Click Configurations and click on Setup. To create the setup, open Setup Creation form. Enter the values of type DL number, station code, station name, number of digitals and number of analog signals in the station. Click on Save. Options available in the screen. Save to save the current record. Delete to delete the current record. Close the setup form. Click on Save and close the software and again rerun the Nmdl software. Caution: this screen is to be used only to add new data logger or mini data logger to the existing setup. Section control entry. Objective: for grouping some stations under one section. Prerequisite object: total network configuration should be done. Output: selected stations should come under one section. To get this option, run Nmdl software. Click Configurations and click on Control Sections. New section. When this option is clicked, a screen will appear. Then enter a new section in the screen. Save to save the particular selection selected. Update to update the selected control section. Close to close the form. Communication settings, communication port setup. Objective: to open the communication ports for logging the database. Prerequisite object: in the computer system, 2 serial ports should be in working condition and at least 1 serial port should be freed. Output: system port and baud rate will be defined and will be opened using software. To get this form, run Nmdl software. Click Security and click on Login. Enter valid username and password. Click Configurations and click on Communication Settings. In this form, the network is selected as communication protocol, number of ports of computer through which packets are to be received. The port names and baud rates can be set. Port: name of the port. Baud rate value. Apply to apply the changes. Note: if only one data logger is connected to a PC, then select Debugger Radio button. Digital functions entry. Objective: to enter the digital signal types and their properties. To get this option, run Nmdl software. Click Security and click on Login. Enter valid username and password. Click Configurations and click on Digital Functions. Options: Auto Group for grouping of relays. Save to save entered values. Delete to delete the selected record. Print to print digital type values. Exit to close the screen. Analog functions entry. Objective: to enter the analog signal types and their properties. To get this option, run Nmdl software. Click Security and click on Login. Enter valid username and password. Click Configurations and click on Analog Functions, Analog Signal Types Entry Form. The RDSO analog fault logic specifies 99-06, the variation of voltages related faults based on a nominal value for each analog signal type. The entry for the same is provided in the screen. Save to save the record. Delete to delete the selected record. Print to print digital type values. Exit to close the screen. Data entry of digital and analog functions. Digital signal entry. Objective: to enter the digital signal names and their properties. To get this option, run Nmdl software. Click Security and click on Login. Enter valid username and password. Open minimized window, visible bottom of the screen. Select the station name if not existing in any minimized windows. Click on Data Entry and click on Digital Signals. To enter the new and modify the existing values, click on the row to which the signal was connected. Type the signal name, select the type of digital signal from the list as user enters in SIG type column. Available types list will be displayed. Select the contact type as user enters in CNTCT. Type column list will be displayed with two values front and back. Click on Next or Previous row to save the record. Add relay to include a particular relay. Delete relay to delete a particular relay. Duplication informs if any duplicate entries are present. Analog signal entry. Objective: to enter the analog signal names and their properties. To get this option, run Nmdl software. Click Security and click on Login. Enter valid username and password. Open minimized window, visible bottom of the screen. Select the station name if not existing in any minimized windows. Click on Data Entry and click on Analog Signals. To enter the new and modify the existing values, click on the row to which the signal was connected. Type the signal name in Channel Name column. Select the type of analog signal from the list as user enters in Channel Type column. Available types list will be displayed. Enter minimum and maximum voltages, multiplication factor, alarm start, alarm to time, description and unit values in respective columns. Click on Next or Previous row to save the record. Note: if the data logger is new, card type is new data logger, then instead of channel number, card number is displayed. For every card, there exist 24 inputs. In every card, channel number 0 is temperature, 1 to 16 are the AC, DC or channel inputs, 17 to 24 are for ADC analog inputs. Maps entry. Objective: to add new station layout to the database for viewing the online or offline simulation. To get this option, run Nmdl software, click Security and click on Login, enter valid username and password, click on Configurations and click on Maps Details. To add the new simulation layout, open Map Entry screen. Click on Empty Row. Enter station name, select the name of file. Enter left and right station names. Click on Save button. Clear to delete the record. Save to save the record. Close to close the screen. Online working of Nmdl. Latest data and time. Objective for knowing whether data logger is in link or not and it is sending the valid packets or not. To get this option, whenever Nmdl is executed, the screen will be displayed and it has no option for closing. Depending on the received packet, different letters will be played with date and time. D identifies that digital relay change record came. A identifies that analog record came, which identifies voltage fluctuation occurred. T identifies that time record came, which specifies that no digital or analog input has changed since 1 minute. H identifies that R packet record came. For every 34 minutes, each data logger will send final status of all digital inputs. OTH identifies remaining all packets other than the DATHM. R identifies that data logger reset record came. M identifies that modem CD on indication record came. Color indications are provided according to data receiving in online. Red if there is no data from last 5 minutes. Green if there is heavy duplication of data is coming. Black, online data indication. Blue, data logger supply channel low. Purple, data logger supply channel high. Select stations. To get this option, run Nmdl software. Maximize the minimized window available bottom of screen. Click on Select Stations tab. Online status. Objective to know the latest status, final status of digital signals and current voltage of analog signal and signals change time. Output. Final status of digital signals and final voltage of analog signals will be shown. Temperature inside the data logger will be displayed. To get this option, run Nmdl software. Maximize the minimized window available on bottom of screen. Click on Online Status option. To see another station information, run Nmdl software. Maximize the minimized window available on bottom of screen. Click on Select Stations. Select the station name and then click on Select button. Click on Online Status. Latest digital signals status with number, name, time status. Analog signals voltages with channel number, name, date, time, voltage. Online time wise. Objective to know the current changing events status of digital signals and voltages of analog signals. Output displays the current changes in status of digital signals and change in analog voltages. To get this option, run Nmdl software. Maximize the minimized window available on bottom of screen. Click on Online Status option. Click on Select Stations. Select the station name and then click on Select button. Click on Online Time Wise. Online Simulation. Objective to view the current relay changes in the station layout. Input. System should log the online data. Output. The current relay changes status of some relays like signal, track point and gate indication. Their status changing date and time will be displayed in the simulation layout. To get this option, run Nmdl software. Click on Online Options and click on Simulation, or click on Simulation icon on the toolbar. Options. Latest relay received. Latest received relay information for selected station. Latest route relay. Latest operated route relay. To see another station layout, right-click on Online Simulation. Stations list will be displayed. Select the required station name. Online faults. Objective: viewing the current occurring faults in the station. Prerequisite: corresponding faults should be entered. Output: occurring faults will be displayed. To get this option, run Nmdl software. Click on Online Options. Click on Faults. List of occurred faults in all stations. Station name, fault message, occurred time and involved signals information. To recognize the fault, click on column, click on Recognized button. Authorization form will be displayed. Enter username and password. Press OK. To clear the fault, first recognize the fault and then click on Clear column, click on Clear button. New form will be displayed. Enter username and password. Press OK. Cleared fault will be removed from the list but available in the database. Examples of fault logics. Logic for fault alarms. Fault name is signal bobbing. Fault logic is the time difference between ECR up to down to up is in between 500 millisecond to 2 second, which should be taken as one count, and for satisfying the fault logic 2 to 3 counts should happen within 10 seconds. Fault name is track bobbing. Fault logic is the time difference between TPR up to down to up is in between 50 millisecond to 1 second, which should be taken as one count, and for satisfying the fault logic 2 to 3 counts should happen within 10 seconds. Fault name is point bobbing. The time difference of NWKR or RWKR up to down to up is in between 500 millisecond to 2 second, which should be taken as one count, and for satisfying the fault logic 2 to 3 counts should happen within 10 seconds with TPR up. Fault name is point failure. When WNR or WRR picks up, it has to wait for 20 seconds. If NWKR or RWKR is not picking up, then it should trigger this message. Logic for unusual incidents alarms. Unusual incidents name, late start of train. Unusual incidents logic is berthing track down, HECR or DECR up, signal replacement track down, time difference between time of occurrence of B and C is more than time defined by user. Unusual incidents name, overspeeding of train. Unusual incidents logic is T1, T2 and T3 are track circuits in sequence. Length of T2 is fed in the logic option. Counter starts when T2 goes down with T1 already down. Counter stops when T3 goes down with T2 already down. Time interval between A and B is less than length of T2 divided by maximum permissible speed by more than 10%. Logic for unusual sequence alarms. Unusual sequence name is picking up of track circuit when adjacent track circuits are down. Unusual sequence logic is T1, T2 and T3 consecutive track circuit in sequence. A, T1 and T3 are down. B, T2 is up and not bobbing and remains continuously up for more than 10 seconds. Unusual sequence name is route getting released without all the sequential route relays in the route picking up. Unusual sequence logic is A. ASR up, B. Considered route TSSLR down or TPZR down or TLSR SN or TRSR down, C. Emergency route cancellation NJPR down. Route failures. Objective to view the faults in routes. Prerequisite: route failures faults should be entered. Output: the sequence of relays in route due to which relay the route was not set. To get this option, run Nmdl software. Click on Online Options. Click on Route Faults. Miscellaneous faults. Objective to view the remaining types of digital faults. For example, button relay stuck up, premature operation, sluggish operation, crank handle bobbing, late operation, late start, unsafe, timer setting less, timer setting more, etc. Health of the communication link. Objective for knowing the modem's CD status. Output: the modem CD status is displayed in graphical notation. To get this option, run Nmdl software. Click Security and click on Login. Enter valid username and password. Click on Online Options. Click on Link Status. Green: modem status OK. Red: modem CD fail. Black: status not available. Commands menu. Objective for checking the link between computer and FEP or data loggers or mini data loggers. To get this option, active Nmdl. Click Security and click on Login. Enter valid username and password. Click on Commands. New form will be displayed with caption Commands menu. Different options in that screen. Link check is used to check the link between computer and FEP or data logger or mini data loggers. Get time is used to get the time from data loggers or mini data loggers. Set time is used to set the time in the data loggers or mini data loggers. Modem reset is used to reset the modem in the selected data logger. But to reset any modem, the corresponding data logger should be in the link. Set pointer is used to set the data sending pointer in the data logger to which the selected data logger will send from this forward or backward pointer. Set pointer. The setting of pointer is of three types: forward, backward, complete backward. Click on Settings and click on Commands, and now click on Set Pointer. Forward. When the forward pointer setting is used. Forward pointer setting is used when a data logger network is bidirectional or more. Every data packet comes to the control place from more than one direction. If the network link breaks and again makes after a certain time interval, all the packets that have been generated during this time interval in each of these data loggers will try to rush through the newly re-established connection with maximum speed. Hence, the network will become choked up due to these packets. To avoid this network traffic, the forward pointer setting command is to be sent to each of these data loggers individually, so that this duplicate data is cut at the source data logger itself. How to send the forward pointer setting command? For sending the forward set pointer command, we are maintaining the latest or recent high sequence number and packed time. With this highest sequence number and packed time, we are making the forward set pointer command for selected station and port. Backward. When the backward pointer setting is used. If there is a situation where the data logger link fails for a particular duration and after some time the modem port stops working perfectly. When again the system is restarted, the data logger sends packets from that particular instance only. The packets in between the time interval, the data logger link modem fails and data logger stops working will be lost. At this particular situation, backward pointer is set to get the lost packets. How to send the backward pointer setting command? For sending the backward set pointer command, we must require to which sequence number and packed time we have to send that command. For that, we provided an option for selecting the date and time from where the data we want. We can get the sequence number and packed time as per selected date and time or next minimum packed time and sequence number as per selected date and time if the data present in the database otherwise gives a message data not available. With this sequence number, packed time, we are making the backward set pointer command for selected station and port. Complete backward. When the complete backward pointer setting is used. If there is a need of already received data packets, then the complete backward setting command is to be sent to each of these data loggers individually. How to send the complete backward pointer setting command? For sending the complete backward set pointer command, sequence number and packed time are 0. With this highest sequence number and packed time, we are making the complete backward set pointer command for selected station and port. To get this option, run Nmdl software. Click on Settings and click on Commands and now click on Set Pointer. New form will be displayed with caption setting transmitting pointer from. Use based replacement. Objective: to maintain the lifetime details, location details and replacement details of the equipments like bulbs, point machines and tracks used in the station. To get this option, open Nmdl software. Click on the Select Stations tab and then select Section Control and Stations. Click on Data Entry tab, select a relay or bulb for entering the details by click on Add Relay or Add Bulb. Click on Data Entry tab, select a relay or bulb for deleting the details by click on Delete Relay or Delete Bulb. Use Based Replacement Bulb Details Entry. Objective: to enter the details of bulbs such as gear number, start time, want time, replacement times. To get this option, select a signal and click on Add Bulb button. Then it will ask for authorization, username and password. After enter the valid user name and password, that screen will appear.